Assalamualaikum warahmatullahi wabarakatuh. Welcome back to my lecture video, and we should continue with the chapter of dynamics on the subtopic of graphical solutions. So this is actually one way of many ways in order to solve any dynamics questions. So we have motion if erratic. So this means motion is unstable. So it's unpredictable. So it moves up and down, for example, or right to the left unpredictably. So then it can be described by a graph. So if one of these graphs is given, so then the others can be established using the differential relationship between A, B, S, and T. So we have this graph, for example, this movement, and then the velocity, for example, starts to slowing down and then raise it up again and stop at this point, for example. All right. So we have the changes in meter distance over the time. So this gives the value of v. All right. So and this is v and number 2, for example. This is v number 1, and it stopped at v number 3. And of course, it comes from the origin of v naught. Okay. So this is what we call the motion of this erratic. Right? So we can imagine from the velocity of a car, for example. All right. So this is again the equation of A equal to dv over dt. Okay. So the equation or relationship for A as well as v and A ds equal to v dv. So these three equation is very crucial for the time being for all of you to remember, to understand, or even to memorize. Right? So the first equation for acceleration, so second equation for speed or velocity, and then this is again for so acceleration and v. Okay, so what we don't have over here is, so we have no t. We have a direct relationship between speed, the distance as the velocity. All right. So unlike the first and second equation, so we have parameter of a, the acceleration v, as well as st, the time. Similarly, for the second equation, so we have v for the velocity, s for the distance, as well as st. But for the third one again, so we don't have t, the time, but we do have acceleration, the distance, as well as the speed or velocity. And then example number 3. So this is a good example on how we can understand the graphical solution. Okay, so a particle moves along a horizontal path with a velocity of v. So this is the speed of this particle. All right. So given as 3t square minus 6t. So this is the horizontal line or the horizontal parts of this particle which is moving from O. Okay, this is the origin. Where t is the time in seconds. If it is initially located at the region of O over here, okay, determine the distance traveled in 3.5 seconds and the particle's average velocity. So we have to determine, okay, we have to evaluate first the distance of the particle which is traveled in 3.5 seconds. If you refer to figure A, so this is the location. Okay, so this is the location as we need to define, or we need to determine, okay, in time of 3.5 seconds. So this is for first question. Okay, and then the particle's average velocity and average speed during the time interval. It means before from 0 up to 2 seconds. Okay, so this is S number 1, for example. Okay, from 0 and then back to 0 to S number 2, and then this is the final one, which is S number 3. Okay, and then sorry, so this is first the origin. Sorry, this is the origin. This is S number 0. This is number 2, number 1 over here. This again, this is 0. Sorry. So comes from 0 to this direction. Okay, and then S1 back to 0 before it comes to this S number 3. Okay, this is S number 1, which is the 0 position. So this is again, so S number 2 and the S number 3. So we need to find the particle's average velocity at this region. This region Y, for example, and also X, for example, and Y region. So this is the graph. We can understand, or we can actually represent the displacement or the movement of the particle, right? So the origin start from 0, 0. Okay, the coordinates, and then this is the y-axis represent v, the speed, and x-axis represent t, the time. Okay, so what we can understand from here is start from 0, and then it become to minus 3 meter per second. So this means this is in the negative direction, backward, or the opposite directions. So this is after 1 seconds. Okay, after 1 seconds here, after 1 seconds. So the particle move or speed at minus 3 meter per seconds. Okay, here negative. And then this is at time equal to 2 seconds. So the particle is having zero speed. So V equal to 0. Okay. And this is at V equal to 3t squared minus 6t. Okay, so minus 60. So this is the time which is given from this equation. Okay. Here, positive motion is to the right, measured from origin in O, figure 12.6a from here. This means it's moving to the right. Is actually positive direction. Okay, or we can simply denote at the beginning of the solution. Okay, here. So to the right means positive. Okay, since V is function of time, so the position as a function of time may be found by integrating V equal to ds over dt with time equal to 0 and s equals to 0. So this is what I have mentioned earlier, the relationship between Vs and t. And then again, you take value of V. This V, this is coming from equation where 3t squared minus 6t. So you substitute into this V, and this gives you the following equation. Okay, and then again, in order to remove the t, okay, to make it disappear, you need to integrate both sides. Okay, this is ds position or distance from 0 up to s, and then we have time from 0 up to t, and you need to integrate 3t square minus 60. So simply we can write this equation where 3t to the power of 3 over 3. Okay, so minus 6t to the power of 2 plus plus 2. Okay, so cancel out this and this, and this one and this equal to 3, sorry. And then we have 3t to the power of 3 minus, this is 3 2 square over here. Okay, so this is the final equation of s, the distance, in terms of t, times. Okay. Now, some notes over here. In order to determine the distance traveled in 3.5 seconds, so it is necessary to investigate the path of motion. So if we consider a graph of a velocity function, figure 12.6b here, okay, this one. So then it reveals that for t equal to bigger greater than 0, which, smaller or lesser than 2 seconds, the velocity is negative. It's actually from here. All right. So because it moved to the left, okay, opposite to the uh, direction we have defined, where to the right is positive, is over here. Okay, it's over here. So, but in this illustration, so from origin 0 to time equal to 2 seconds, this means within 2 seconds, the particle is moving to the left, opposed to the one we have defined, which is positive to the right. So velocity is a negative, which means the particle is traveling to the left. And for t greater than 2 seconds, positive velocity. Okay, because after 2 seconds, now particle is moving to the right. Okay, parallel with the position we have defined earlier. And hence the particle is traveling to the right. So also note that v equal to 0 at t equal to 2 seconds. Okay, the particle's position when t equal to 0, t equal to 2 seconds, and t equal to 3 seconds. So there are three conditions or three situations where t equal to 0, t equal to 2 seconds, and t equal to 3.5 seconds. Okay, so we can determine from equation 1, this yields as in time of t equal to 0, so this is actually 0. So as when time equal to 2 seconds, this is actually negative 4.0, and s equal to t equal to 3.5 seconds, so m, or the distance, is 6.125. So we solve this 3 using this equation. Okay, so just substitute the value of t. Okay, the first t is 0. So first t is 0 into this t, and of course s equal to 0. And then the second t, we have t equal to 2 seconds into to here. All right. Now we have 2 to the power of 3, and then minus 3, 2 to the power of 2. So this gives you negative 4 meter. Okay. And then finally at t equal to 3.5 seconds. So again into this equation, so t now 3.5, the second t also 3.5, so they give you positive 6.125 meter. Then altogether, the total distance st traveled by this particle, all right, is equal to 4.4 plus 4.4, another plus 4.125, regardless the negative sign, because the negative sign is showing you the direction of the particle, so it's moving to the left, but still the particle is traveling with a certain distance. That's why we just add up this value 4, right? Or just neglect the value of negative. Okay, the first t, 4 plus 0.5.6.125. Okay, the first distance 40, and then the second distance and the 40, because it start moving to the right. So the first one here 4 meter to the left, negative direction, for example, and then it start moving to O position again, original position another 4 meter, and then plus here to time equal to 3.5. This is 6.125 meter. So altogether we have 4 meter plus 4 meter plus 6.125, and this gives you approximately 14.1 meter after 3.5 seconds. Right? So this means this particle has been traveled about 4.1 meter after 3.5 seconds. Okay, after 3.5 seconds. This is what required by the question. Okay, and then how about the average speeds? Okay, the displacement from t0 equal to 3.5 seconds. Okay, from time equal to 0 and time equal to 3.5 seconds is actually the difference between distance covered by particle after 3.5 seconds minus, okay, the distance of the particle in the beginning or during t equal to 0 seconds. That means, so we have 6.15 over here, okay, compared to the t equal to 0, okay, minus 0. Okay, so you're just comparing these two positions. Okay, so minus 0, this gives you 6.1125 meter. Okay, so the average velocity is, okay, the changes of distance, okay, over changes of time. So we have 3.5 seconds minus 0. So the average speed is 1.75 meter over seconds. Okay, and then the average speed is defined in terms of the distance traveled as t. This positive scala is, okay, this is if we consider the total s. Okay, the total s covered or traveled by the particle, which is 14.125 over here again. So we have obtained it earlier. So the total s or the total distance traveled by particle 14.125 meter over 3.5, okay, seconds minus 0. So at the beginning start at 0 seconds. So they give you 4.04 meter per second. Okay. Again, this is for the average speed for the distance, the total distance traveled by a particle. So in this problem, the expression is A equal to dv over dt. 6, okay, this is an additional note. So this equation is actually not, it's not constant. Right? And then move on to example 4. Car in figure 12, 14a starts from rest, and so this is the car. So this is just the illustration. So figure 12.14a starts from rest and travels along a straight track such that it accelerates at 10 meter per s square, okay, for 10 seconds. So this is the acceleration for this car, okay, for first 10 seconds, and then decelerates, okay, pecutan decelerates at 2 meter over second square. So draw the Vt and St graph. Okay, so this is the relationship between speed V and T, and then this is the relationship between S distance and T graph, and determine the time T prime. So this is a new T, so needed to stop the car. This means this is V2 equal to 0. Okay. So to stop the star, so how far has the car traveled? So again, we need to find the total S at t equal to t prime, right? At the new t prime. Okay, so you need to find the new t first before you find the total distance of this car has traveled. So now in order to come out with VT graph, this is the speed and time graph. So since again dv equal to a dt, this is from a, this from this relationship. So a equal to dv over dt. The VT graph is determined by integrating the straight line segments of the AT graph. So using the initial condition, so v equal to 0, this is the condition where t equal to 0 and then v equal to 0. So we have the first question or first condition, so within 10 seconds. Okay, sorry, 10 seconds. So this is the speed. Okay, so this means from t equal to 0 up to t equal to 10 seconds. So the speed is given by this value, 10 meter per square root, square s square, sorry. So dv, so this is actually a. So this is coming from here. This equation, this a. And then substitute this value a, get back to this equation. Okay. So dv 0 up to v, and then this is equal to 0 up to t, 10 d, 10 dt. All right, and then we can simply solve the equation to get this formula v equal to 10 t. All right. Okay, when t equal to 10 seconds, so when we have t equal to 10 seconds, what happened to v? So substitute this value t into this equation again. V equal to 10 multiplied by t, and then 10 multiplied by 10, so we have 10 dot 10, so we got 100 meter per seconds. Okay, this is unit for v, speed, velocity. So using this as the initial conditions for the next period time, the next time period, so we have t which is greater than 10 seconds, okay, but lesser than t prime. The new t we are gonna find. Okay, so a equal to minus 2 meter over seconds square. So we got the deceleration actually. So this is happening, the deceleration happening after t equal to 10 seconds, but lesser than t prime because the car has stopped at t prime. So a equal to minus 2, this is actually from this condition, decelerate. Okay, so after 10 seconds, right, after 10 seconds, here are the seconds, and then the car start to decelerate at 2 meter per second square. This means this a is negative a. Okay, negative acceleration. Okay, so a minus 2 meter per second square. So we derive this, and then we have dv over here. So this is similar from this equation. Okay, so into this equation, so instead of 10, so we have minus 2. Okay, but it doesn't start at 0, but it start instead we have 100 meter per second. So after 100 meter per second, remember just now, so our car start to decelerate and stop. Okay, until v, and then here also after 10 seconds our car start to decelerate until t. Okay, t means this is the t, this is actually equal to t prime, the new t where the car stop. Okay, and then solving this we give you minus t 2t plus 120. So try to solve this, and you substitute the value of 100, okay, into this v, okay, and then similarly this 10 into this t, okay, So you will get something like 120, and then when you sum up, add up, you will get 120. So try to integrate this equation and solve in term of v. Okay, so you will get the final equation, which is minus 2t plus 120 meter per second. So when t, again in this t is actually t prime. Okay, so we require v equal to 0. Okay, v equal to 0. So add here, this means from this equation, okay, so we give 0 value at v. Okay, so then we have minus 2t plus 120. So you have 2t equal to 120. Now we have the t equal to 660 meter. Okay, so this is the answer. Okay, the t prime, this is, sorry, this is not meter, but this is seconds. Okay, because the symbol is t times, so the unit is seconds. So this is the new time. Okay, time prime, where the car stop at v equal to 0. So the more direct solution for t prime is possible by realizing that the area under the AT graph is equal to the change in the car's velocity. So the area under this AT graph, okay, so this is the AT graph, okay, the A versus T graph, the acceleration versus time. So the area under this graph is actually equal to the change in car's velocity. Okay, this means the changes of speed or velocity give speed. Okay, so it represent under this graph the area or the space under this graph. So we require changes of v equal to 0. Okay, so this is the condition. We require changes of v equal to 0. And this is equal to A1 plus A2, the area under graph number 1 and area graph number 2. Okay, so again, this is for the first 10 seconds. For the first 10 seconds, we have the first 10 seconds over here. So we have the speed at 10 meter, sorry, the acceleration at 10 meter per second square. So this is the second speed, A2, after 10 seconds up to t prime. Okay, so we don't know yet the value of t prime. This is only the second alternative on how to solve the first one. Okay, then we try to sum up the value A1 plus A2. So this is actually the area of A1 is actually, okay, the width of this box, for example, multiplied by the height of this box. Okay, so the W multiplied by the L. So we get that 10 multiplied by 10. Okay, this 10 multiplied by this distance. So similarly, this is for A1, and then for A2, so we have the second box over here. Okay, so we have, here is actually minus 10. Okay, sorry, this is T. So the L over the W, for example. So this is the L, for example. So this W is actually T prime minus 10. Okay, this W is T prime minus 10 here. So this is T prime minus 10. This is for the W, and then this is for the L of the second area. This L, okay, the L for the second area. This is minus 2, as can we remember just now. So the car start to decelerate at minus 2 meter per square seconds. So multiply this and rearrange the equation. This will give you t prime equal to 60 seconds. So another solution for ST graph. So we have seen the V t graph. Okay, finally we are able to plot the vt graph. All right, so this is our speed. So let me change to another color. So the y-axis so represent the v, and then the x-axis represent the dt, and of course the initial position, origin position, so always 0. Okay, and then so the first 10 seconds over here, so t equal to 10 seconds, right? So the speed increase, spike up to 100 over here meter per seconds. Okay, so how we calculate this is actually from here. Okay, 10 equal to 10, t equal to 10 seconds, so the value of v is 100 meter per seconds. Okay, so again at t equal to 10 seconds here, so at t equal to 10 seconds, so it spike up to 100, so this is 100 meter per seconds. Okay, and this is actually the equation. Okay, v equal to 10 t, this one. Okay, all right, and then this one after t equal to 10 second here. Okay, t greater than 10 second but lesser than t prime, so this is the relationship. This is the equation of the v. Okay, v equal to minus 2t plus 120, so that's why we put it here. Okay, and the speed start to decelerate. They start to, okay, decelerate up down to t prime equal to 60. Okay, so t prime equal to 60, where at this point v equal to 0. Okay, so the spin after 10 seconds, okay, the speed starts to going down to 0 at t prime equal to 60 seconds. So this is how we draw the vt graph. Okay, what about the st graph? So since ds equal to v dt, so this is how we relate between s, v and t. So similarly, integrating the equation of vt graph yields the corresponding equation of the st graph. So using the initial condition s equal to 0, when t equal to 0, we have the first condition t which is equal to 0 and greater than 0, t in between 0 and 10 seconds actually. Okay, so v equal to 10t meter per square. So this is from the previous slide. Again, this is from here, v equal to 10t. Okay, so we try to derive these two. Okay, derive these two, ds over v dt, v here. So this v go to this one. Okay, so this is actually v. Okay, then we have dt, so integrate from 0 up to s for distance, and then 0 up to t for time. And then solving this, so we have s equal to here 5t square meter. Remember, s is distance and then unit is meter. So this is the first relationship we are able to generate. Okay, s equal to 5t square meter. And then what happened when t equal to 10 seconds? Okay, so similarly, just substitute this t into this equation. So we get s equal to 5 10 square. This is equal to 500 meter. Okay, this means after 10 seconds, so our car have moved up to 500 meter. Okay, so using this initial condition, so we are able to find the value of remaining t. Okay, so in between 10 seconds, I mean greater than 10 seconds, but lesser than 60 seconds. Okay, so again, this is the first condition where the car start to move from t equal to 0 seconds up to 10 seconds. And then this is the second condition. What happened to the car? So the position, especially the position of the car when t equal to 10 seconds. And then this is the third condition where the car has stopped at t prime, which is 60 seconds. So V, again, this V is coming from previous discussion, this V, all right? So the one I highlight over here, V equal to minus 2t plus 120. So do not, or you don't need to find the V. It has been analyzed earlier. And the relationship again, so this is ds using the same relationship over here, this one, okay, into this. Let me change the color. Okay, again, use this relationship, okay, and then we come here. But this time around, we have after 500 meter for the distance, because we have seen that we know that after 10 equal to 10 seconds, t equal to 10 seconds, the time, so it travel up to 500 meter. This means we try to start analyzing after 500 meter. So for this particular condition, so our car start to drive from 500 meter and s distance, the unknown distance. Okay, so similarly for time, so it start to move after 10 seconds to this unknown t. All right, and then after derivation, okay, the are able to find this relationship. Okay, so this is actually s minus 500. Okay, it's over here, s equal to 500, and this part is actually this. Okay, so we have t 2t. Okay, so squared over here, or t squared over here, after you solve or you integrate this value, and you integrate this value, and then you will get this, okay, in this relationship. Okay, and this is up to you, include or obtain value of 10, this 10, okay, into this t, okay, into this t, this 10 also into this t, so you will get 120 t over here. Okay, this is really t. And then so this the equation will give you the relationship between s and t, or the equation of s in term of t. Okay, so you have seen that the car stop at t prime, the new t equal to, which is equal to t 60 seconds. So the position is s into this t, and s into this t will give you 3000 meter or 3 kilometer. Okay, so the ST graph is shown in figure 12.14c. Okay, so it's shown here over here. So again, it start from distance 0 meter, okay, and 0 seconds. Okay, distance in terms of meter and in terms of seconds, this is the t. So always start from 0. Okay, this is meter, don't get confused. And then as it move to 500 meter within the first 10 seconds over here, and this is the formula involved, okay, related to this graph. And then for the second one, so we have after 500 meter, which we have been analyzed in this part. Okay, this is the equation from here. Okay, sorry, from here. Okay, and we got this equation and we put it here. Okay, this equation. And then here again up to 3000. Okay, this is what we just determined, or we just obtained. Okay, 3000 meter. at the time of 60 seconds. Okay. So just note a direct solution for S is possible when t prime equal to 60 seconds, since the triangular area, again, if you refer to this equation, this relationship, okay, the one I highlight over here, so the VT, so if we try to find the area under this triangle form or triangle shape, this is actually the value of S. Okay, so we try to find the T, okay, the T prime underneath T, okay, for this one. Okay, and then possible T equal to, since the triangle everything with the displacement of S. Yes, this gives the displacement of S from T from 0 to T 60 seconds. So hence, so this is actually the formula of triangle. So we have 1 over 2 60 s 100 and 100 meter per second. This is actually the, okay, this one, the height of this triangle. So this is 100. Okay, so this is actually t, sorry, from here to here. So this is 60. So the area is actually for the s, but the changes of s is minus s minus 0. Okay, it's actually minus s minus 0. So we have over here s minus 0, this is start from s, so this is n, but at s, for example, the maximum s, so s minus 0, so how far it goes from 0 to s. So we'll give s over here, okay, s minus 0 is s, and this is equal to 1 over 2, the formula for the triangle, 60s multiplied by 100 meter per second, so they give you 300 meter. So this is how, this is actually the alternative solution you can find using the VT graph. Okay. And thank you very much for your attention. So we will see the kinetics analysis in my next video, and see you again.